Welcome back to the Interesting Science channel. Dear friends, for the first time in history, physicists have discovered extremely rare ghostly particles. They are formed from the chain of fusion reactions occurring in the Sun's core. This discovery has brought scientists one step closer to understanding the processes inside the Sun's core. The research was first published in the journal Science on July 16, 2020. So today, Interesting invites you to explore the mysteries of the newly discovered ghostly particles. Now, let's begin our journey of discovery. The Sun is the central star of the solar system, a giant plasma sphere. With a diameter of up to 1.36 million kilometers, the Sun is the most important source of energy for life on Earth. For a long time, scientists have identified two types of nuclear fusion reactions occurring in the Sun's core. First is the proton-proton fusion reaction, which converts hydrogen into helium. This is considered the most common fusion reaction occurring in the Sun's core. Therefore, scientists believe that these common reactions produce 99% of the Sun's energy. Second is the CNO cycle. This is a rarer and more specialized cycle. In it, hydrogen is combined with helium through carbon, nitrogen, and oxygen. Both the proton-proton fusion process and the CNO cycle produce different types of neutrinos. They are called ghost particles because they have almost no mass and can pass through any ordinary matter without leaving any trace of their existence. Physicists previously often detected neutrinos from the Sun, but all of them were produced from the process of converting protons into helium in hydrogen fusion. However, at the International Neutrino Conference held on June 23, 2020, scientists worldwide, researchers from the Italian National Institute of Nuclear Physics announced that they had for the first time detected neutrinos produced from the CNO cycle in the Sun. This research was first published in the journal Science on July 16, 2020. Scientists believe that a comparison can be made between neutrinos from the CNO cycle and neutrinos produced from proton-proton fusion. They can calculate the percentage of the Sun composed of elements heavier than hydrogen, such as carbon, nitrogen, and oxygen. As mentioned, neutrinos have almost no mass and can pass through any ordinary matter without leaving any trace. To detect them, researchers from the Italian National Institute of Nuclear Physics had to use the Borexino experiment set up deep underground. They used the Borexino detector with an 18 meters high tank containing about 280 tons of scintillating liquid. These liquids can emit light when the electrons inside them interact with neutrinos from the CNO cycle. The Borexino detector is placed deep underground, isolating it from cosmic background radiation on the Earth's surface. Additionally, this device is equipped with extremely sensitive sensors that can capture neutrinos emitted from the CNO cycle in the Sun. Without this shielding, scientists would find it difficult to detect these extremely elusive particles. The Borexino experiment is an international collaboration with researchers from Italy, France, Germany, Poland, and 3 U.S. universities: Princeton, Virginia Tech, and Massachusetts. According to scientists, neutrinos are very elusive subatomic particles formed from various nuclear fusion processes. They have almost no mass and travel through the universe at speeds close to the speed of light. Researchers have detected countless neutrinos in the universe, from supernova explosions to the cores of stars, and even in nuclear reactors on Earth. Therefore, scientists estimate that the number of neutrinos in the universe may be 1 billion times greater than the number of protons. Despite being extremely common, neutrinos remain a mystery to physicists because they are extremely difficult to capture. Just that you can. Neutrinos can pass through any matter, much like light rays passing through a thin sheet of glass. They can only be detected with super-sensitive specialized equipment, like the Borexino laboratory of Italian scientists. In the late 19th century, scientists discovered many suspicious points about the phenomenon called beta decay. At that time, they found that the nucleus inside an atom could spontaneously emit an electron. This decay seemed to violate two fundamental laws of physics: the law of conservation of energy and the law of conservation of momentum. It wasn't until 1930 that physicist Pauli hypothesized the existence of a particle emitted from the nucleus, which carried the missing energy and momentum. By the mid-20th century, scientists were able to build detectors to search for these ghostly neutrinos. It must be affirmed that the scientists' discovery of ghost particles from the CNO cycle in the Sun is an enormous scientific achievement. With this result, researchers have clarified two nuclear fusion processes, the proton-proton reaction and the CNO cycle. This research can help scientists gain a deeper understanding of the nuclear fusion reactions occurring in the Sun's core. Studying and exploring the Sun has long been a significant challenge for scientists. With the extreme temperatures it generates, it seems scientists have no equipment durable enough to get close to it. In February 2020, the Solar Orbiter probe, a collaborative project between NASA and the European Space Agency, ESA, was launched on a journey heading straight toward the Sun. Its mission lasts 2 years to study reactions on the Sun's surface and the dangers caused by these reactions. Recently, NASA and scientists have released a series of images of the Sun, taken by the spacecraft in June 2020. At this time, the spacecraft is about 75.6 million kilometers from the Sun. It can be said that these are the closest images of the Sun ever taken. But the fire spots in these images taken by the probe are a billion times smaller than the solar flares observed from Earth. These images may help explain why the Sun's corona is hotter than its surface. Essentially, the corona is a region of light emitted from the space surrounding the Sun. According to scientists, the material density in this region is extremely low. When standing on Earth, we can observe the corona during a total solar eclipse. We often think that areas closer to the heat source will be hotter. This can be considered a logical truth deeply ingrained in our thinking. But the Sun is different. At its core, where nuclear fusion reactions occur, the temperature can reach about 15 million degrees Celsius. And this is where the Sun's energy is generated. The farther away from the core, the lower the temperature. When reaching the surface, its temperature is only about 5,500 degrees Celsius. However, the Sun's corona does not follow any logical rule. In areas very far from the Sun's surface, the corona can reach temperatures of over 1 million degrees Celsius. This is still considered one of the biggest mysteries about the Sun that scientists have not been able to explain. But with the new observation angle from the Solar Orbiter probe, scientists hope to partly decode this mystery. Studying the Sun is extremely important, helping scientists plan responses to extreme harmful weather phenomena, such as coronal mass ejections. This event can paralyze GPS systems, cause power grid failures, leading to blackouts and food shortages on a global scale. The UK Space Agency, UKSA, said it could take many months or even years to fully recover from the damages. Currently, scientists still cannot find a method to accurately predict coronal mass ejections from the Sun. The Solar Orbiter spacecraft is equipped with 10 instruments, including 6 dedicated to observing the Sun's surface. The remaining 4 instruments will measure environmental parameters, including subatomic particles, solar wind, and magnetic fields. The Solar Orbiter spacecraft, with its $1.5 billion rocket stage, continues its journey toward the Sun. As planned, the spacecraft will approach the Sun at a distance of 48 million kilometers, closer than Mercury. And the spacecraft certainly cannot fly closer, as the temperature from the Sun at that point would cause the onboard telescope to burn gravity to adjust its orbit into an ellipse, allowing it to fly over the Sun. Scientists expect this to be the first opportunity to observe this region and understand the mechanism generating the star's magnetic field. Let's look forward to 2021 to see what achievements this probe will bring. So today, we have explored the newly discovered mysteries about the ghost particles emitted from the CNO process in the Sun. Wishing you very relaxing moments with this video. And now, please continue selecting videos on the left or right of the screen to explore more incredibly interesting mysteries of the universe. See you all in the upcoming videos. Goodbye, everyone.